Here's an example of that same kind of problem. Okay, we have sprinters in a race. There's 5 of them. We're going to award medals to the first, second, and third place sprinter. How many ways could the first, second, and third place sprinter medals be awarded? So we're talking about Jamie and Hannah are racing with Cassie and Owen and Aaron. Okay? So how many ways could we determine the first place medal? Yeah? There's 5 ways for first place. And then 4, and then 3. So we have 60 different ways that we can award first, second, and third place. Okay? Now, in the second part of the question, this is a different question. I'm not going to award medals. It's just that the top 3 finishers are going to qualify for the relay team. So how many ways could I choose the top 3 finishers? I mean, I'm not going to choose them, but how could they choose themselves? By being the fastest. How many ways could the top 3 sprinters? Okay. So think about this. We've got 5 sprinters. 3 of them are going to be yeses. They're going to go on to the relay team. And 2 of them are going to be no's. Okay. And we don't know which ones are which. It depends on how they finish in the race. But how can I arrange those 5 letters? You know how to do it. Over 2 factorial. So 5 factorial over 3 factorial, 2 factorial. So that works out to be 5 times 4 is 20 divided by 2, so only 10 ways can I choose those top 3. And if you put it in your calculator, you would get 10. So I did 5 times 4, and then I stopped because I knew the 3 factorial would cancel with the 3 factorial. So 5 times 4 is 20. 20 divided by 2 is 10. Now 1/6 the number, okay? How do we write this in factorial notation? How do we write this one in factorial notation? 5 factorial over 2 factorial. Okay? So notice the difference. Here, order matters. Here, order doesn't matter. Here, I'm taking the number I have and dividing by the number I'm not going to choose. Here, I'm taking the number I have, dividing by the number I am going to choose and the number I'm not going to choose. And that's the difference. If order doesn't matter, then we're not interested in the way that those 3 are ordered, the winners. We don't care about them. We just want to know that there are 3 of them. Okay? And that's called a combination. So with permutations, order does matter. That's what we were talking about before. And with combinations, order doesn't matter. And I know that's confusing to you because what do you use every single day when you're here at school? Where order matters. And you call it a combination. Your combination lock on your locker. Right? But that's wrong. It should be called a permutation lock on your locker because the order that you put those numbers in matters. You can't put them in any order you want. That's not true, Owen?
They should not call it a combination.
That's right. I'm glad you agree with me. So with a permutation, we do n pick R. With a combination, we do n choose R. And you've seen that on your calculator in the same location. The formula for permutation we've learned is n factorial over r factorial. N factorial over n minus r factorial. For combinations, it's n factorial over r factorial n minus r factorial. So for combinations, it's the number we have factorial divided by the number we want factorial and also divided by the number we don't want factorial. So which one are we going to have more of? If I've got 5 items, am I going to have more permutations of those 5 or more combinations of those 5? You know what? Let me take a pause here. So we're going to have more permutations sorry, because in a combination, the formula is exactly the same, except we divide by this extra number. And this number, since it's always going to be a whole number, it's always going to be positive, and not a fraction or whatever, when we divide by it, we're going to get a smaller number. So that we're going to always have fewer combinations than we have permutations, okay, because of that extra division that we're doing here. All right, so we'll do a few examples, and then I think we'll do a little board work to practice today because we have the time. And then we will do a little practice on your own. All right, so let's say I have 24 students. Let's see how many students I have in this room right now. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. I have 26. So let's say I have 26 students in this room. And I want to make a group of 3 students, okay? These are going to be my pets that I'm always going to give all the best, I don't know, whatever, the prettiest colored handouts to, okay? So I have 26 students, and I'm going to choose a group of 3 students. How do I do that? Well, it's 26, choose 3. What you want to ask yourself in a question like this from now on, like today we're doing combinations, but from now on you're looking at a problem, you want to say to yourself, well, does the order matter? If I'm choosing these 3 students, does it say that I'm ranking them, or I'm giving them medals, or I'm calling them president, vice president, secretary? It doesn't, right? I'm just choosing the 3, and they're the 3 chosen ones, okay? But the order that I choose them in doesn't matter. So that means it's a combination question, so I use the choose function. 26, choose 3. So that is 26 factorial over 23 factorial, 3 factorial. So I'm dividing by the number I want factorial and also the number I don't want factorial. Okay? That's the difference today. So it's not just the number I don't want, it's also the number I want that I'm dividing by. So that means that I can go 26 times 25 times 24 divided by 3 factorial, which is 6. So the 23 factorial cancels with the 23 factorial that would continue on here, and the 3 factorial is 6. And then I can put that in my calculator, or I can also notice that 6 goes into 24, so I can put in my calculator, oh, and then I know that 4 times 25 is 100. So I could do that whole thing without a calculator. How lovely is that? Okay? Okay, so notice this interesting piece of information. Let's say now I want to choose a group of 23 students from this group of 26. So I want to choose a bunch and exclude 3 people this time around. Okay? Because that's how I roll. You've got 26 factorial then. This time I want 23 factorial and I don't want 3 factorial. So what's going to be my final answer? $2,600 again. So there's this nice symmetry that goes on with combinations. 26 choose 3 and 26 choose 23 are exactly the same because 3 and 23 adds to 26. So this denominator here, when you just look at it, it doesn't distinguish between the ones you want and the ones you don't want. Okay, you're going to get the same number in any case, 2,600. So if I choose 3 students or if I choose 23 students, I'm going to get 2,600 students. Okay? Questions about that? All right. So let's say that I want to be a little bit more discriminating in my group of 3 students. So I have 26 students in this classroom. I don't think I counted Curtis. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 13, 3, 6, 10, 13, 17, 21, 2, 3, 4, 5. I didn't count Curtis. Okay, so that's fine because I don't want to ask Curtis. He's busy. We have 26 students. How many students in here are 17. Put up your hand high if you are 17 years old, so I can count that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I've got 13 of you that are 17-year-olds. So can I assume that the other 13 are 16-year-olds? Do I have anyone younger than 16 or older than 17? Oh, yeah? Okay. And so Krish, you're 18 and? 15. Okay, so I'm just going to lump you guys together as other. How about that? I know that's kind of bad, but I don't want to have any ones, okay? I don't want any singles for a reason. Just makes the problem more interesting. So then I only have 11 of these. Okay, so I have 13 17-year-olds, 11 16-year-olds, and 2 other ages. Okay? So I want a group of 3 with exactly one 17-year-old. Okay? I want a 17-year-old because I want some maturity in the group. And I do have an 18-year-old, but I just have one, and so that wouldn't be fair if I just automatically made it Koresh, and it wouldn't be very random, right? So I'm going to have a group of 3 students, and I want exactly one 17-year-old. How many groups can I make with exactly one 17-year-old? Okay? So this is the interesting piece. When I start to specify my groups a little bit. Well, how many 17-year-olds have I got altogether? 13. And I want exactly one of them. So I'm going to choose one 13-year-old. Okay. Then I have 13 left of the other guys. And I want how many of those ones? 2. Okay. So I have 13 choose 1 times 13 choose 2 because I want one 17-year-old and I want 2 other students. And by other I mean 16 or some other age other than 17. So I'm including all of these guys together as other. Okay? So I have 13 17-year-olds and I want one of them, and I have 13 not 17-year-olds and I want 2 of them. So when I calculate that, I can put that in my calculator, but 13 choose 1, do you know what that is? It's 13, right? If I have 13 students and I'm going to choose one of them, I have 13 ways to do it. And 13 choose 2. Anybody know what that is? It's 13 times 12 divided by 2. Because the 11, because it would be 13 factorial over 11 factorial, 11 factorial, 2 factorial. Let me write that. So the 11 factorial here that comes after the 12 is going to cancel with this 11 factorial. So it's 13 times 12 divided by 2. So it's 13 times 13 times 6. That's what I want to work out. So what does that work out to be? 169 times 6. 1014? So there's 1014 groups that I could make with 3 students and exactly one 17-year-old. Okay? 1014 of the 2600. So, because I could make 2600 groups of 3 before, right? So the difference between those, that almost 1500 students difference, what are those groups? Yeah. Right, or no 17-year-olds, right, is all the other ones. So if I wanted to know how many groups could I make with no 17-year-olds, I could just, I couldn't do it like that. So here's the question. If I wanted to know how many groups I could make with more or less than one 17-year-old, I could just subtract them. Okay? If I wanted to know how many groups I could make with no 17-year-olds, what would I do then? This would change to say 13 choose 0. And what's 13 choose 0? 1, right? If I have 13 students and I don't want to choose any of them, I've got one way to do that. Don't choose any of them, okay? And then here I would have 13 choose 3. So notice these two numbers add to my total. I had 26 students altogether, and these two numbers add to what I'm going to choose. I'm choosing 3 altogether, 1 from the 17-year-old group and 2 from the rest of them. Okay? How about I want at least one 17-year-old? What does that mean if I want at least one 17-year-old? What am I happy with? I'm happy with one 17-year-old, which I already calculated to be 1,014. But I would also be happy with 2 17-year-olds. And I would also be happy with 3 17-year-olds. So how many ways could I have 2 17-year-olds in that group? I'm going to calculate the same way as I did this, only it's now going to be 13 choose 2 times 13 choose 1. So how much is that going to be? That's going to also be 1,014. So all I'm doing is reversing the 2 and the 1 here, but those numbers will be the same, so I'll still get 1,014. How about 3 17-year-olds? How am I going to do that? 13 choose 3 times 13 choose 0. How many ways can I choose 3 students from 13? 13 factorial over 10 factorial 3 factorial times, what's 13 choose 0? 1. So I need to work out what that is. 13 choose 0 divided by 13 factorial divided by 10 factorial is 13 times 12 times 11. Now I'm going to divide by 3 factorial. 3 factorial is 6. So that divides to become 2. So I want 13 times 22 in my calculator. What's 13 times 22? Sorry? 286? So that's the number of groups with 1 17-year-old. That's the number of groups with 2 17-year-olds. This is the number of groups with 3 17-year-olds. So how many groups could I have with at least 1 17-year-old? What would I do? I would add them up, because I want either this situation or this situation or this situation. So whenever you see this word at least, that's telling you that we have ors, and so that's telling you to add. Figure out the different cases and add them together. So it's 1,014 times 2 is 2,028 plus 286. What does that work out to be? 2314? So 2,314 groups have at least 1 17-year-old. So how many have no 17-year-olds? Any ideas? 286. How'd you get that, Demetria?
13 choose 0 times 13 choose 3.
So exactly the same as this. Yeah, and now notice this. If we add 286 to 2314, what do we get? What do you get? 2,600, right? Remember we saw that number before? That's the number of groups I can make altogether, is 2,600. So that 0 17-year-olds, that takes into account all the different groups possible, which is 2,600 altogether. Okay? Coincidence? No. Okay. Do I want to talk about anything else with you? I do. So let us have to look in your textbook on page 725. I want to look at the construct your understanding number 3. And I can't do it with the video, unfortunately, because I can't write on the screen. So I'm going to end the video here.